Okay. This particular presentation is on dynamic analysis, and I have intentionally not specified dynamic analysis of piping. The reason being that in today's session, which is going to last 3.5 to 4 hours, by and large, I'll be talking about the background theory and Caesar 2 implementation. So that's a very important material for those who are interested solely to understand the background theory and how to do it in Caesar 2. However, the one that I'm going to present next week is going to take it at a broader level. What I mean is that most of the real life vibration problems that you are going to address won't have a Caesar 2 best solution. You have to look beyond Caesar 2. And one very important thing is for you to go to the site, take the measurement, or if someone else is taking the measurement, scrutinize the results thoroughly, challenge them, understand what they have done and what they have not done. Information for the rotating equipments also, but I don't know whether any of you is going to have a rotating equipment background. But if you have, or if you don't have, that part of the course is going to help you a lot eventually when you address and resolve field vibration problems. So with this, you can see that the way this course is structured, I'm first going to talk about some basic definitions, and I'm going to talk about the relevant equations of single degree of freedom and multi-degree of freedom. Then I move into Caesar 2, and I'm going to cover harmonic, force spectrum, and in force spectrum, I will be covering the fluid hammer problem and then time history analysis. When I start talking about Caesar, you'll see the importance of the theoretical thing that we are going to cover before we deep dive into Caesar. And as and when required, I'll be moving between slides to kind of tell you, well, this is what we discussed earlier, and this is what you can see now in action. There'll be, as I mentioned, there'll be a lot of information about vibration measurement, the instruments, the calibration of those instruments, and identifying issues with rotating equipment. But that will be the topic of discussion on day 2, which was Saturday next week. Now, the equations and diagrams are generally taken from multiple sources, and to avoid any kind of issues with copyrights and everything, I put the references in a box at the bottom of the slide or sometimes at the top of the slide, and they all are described in detail in the reference section, which is at the end of have approximately 140 slides. So my plan is to go through 70 slides today. So at the end of this 140 slides, you'll have a reference of around 13, where you'll see all those references. Today, after the presentation, approximately half an hour, we're going to keep for the question answer session, but that's not where your question and answer ends. There's a WhatsApp group that has been created by Anup Ankur. You put your questions there. I normally try to respond to questions at the earliest, but Monday to Friday, usually, the office work, I may not be able to respond immediately, but I will respond at the earliest. And today, after the end of the presentation, I will be sending some questions in the WhatsApp group to test your understanding, okay? Whether to answer that or not is your choice. I will be responding to your answers, whether your answers are correct or not, whether there's remarking or anything like that. The last point is this course is mathematically heavy, so you have to do a lot of supplemental studies. So you have to go through all the relevant references are given, but but there is nothing more than what you have studied at your undergraduate in course in engineering maths, excepting probably few things. But those things, again, whenever I talk about maths, I will try to give a physical aspect of its implementation. I mean, what exactly the maths and what exactly are those equations say in the physical space.